challenge problem number 1161. Maximum sum level of a binary tree. Here we are given the binary tree. The level of the root is 1, the level of children is 2, and so on. Return the smallest level x such that the sum of all value of nodes at level x is maximal. As in simple way, we have given a binary tree. We have to return the maximum sum level. That means which level have the maximum sum. For example, we see here, to calculate the maximum level sum of the tree, we need one max variable, and corresponding to its max variable, then we have to need one level variable to store the level of the max variable. So we store the level as an answer, because we have to return the level variables. At the level 1, first we find the sum of the level 1, that is only one element. Then the level 1 have a sum is 1. Then we compare to the 1 and max variable. If 1 is greater than max variable, then we update the max variable is equal to 1, and we also update the answer, its level, then level is also 1. Then we go to at level 2. Here we also calculate the sum. Then the sum of 7 and 0 is equal to 7. Here we also compare the value of second level with first level. If the second level value is greater than the first level, then we update the max value and answer also. Then we update the max is equal to 7 and the level is equal to 2. After that we go to the third level. Third level is there are two elements, 7 and minus 1. Then 7 and minus 1, the sum of the both is minus 1. Here it is less than the max value, previous max, or the max of tree. Then we not update the value of max and level, and simply we return the value of level, because this is the last level. Take another example. We taking another example. Here is also root node have a only. Here we take another example. Root node have a only 1. Then we here update the max is equal to 1 and level is equal to 1. After that we go to level 2. Here at the level 2, there are two elements, 7 plus 9 is equal to 16. Then 7 plus 9 is greater than 1. Then we update the max is equal to 16 and level is equal to 2. Then we also, after that we go at the third level. Third level we try to find the sum 2, 6 and 9 is equal to 17. 17 is also greater than the max value. Then we update the max is equal to 17, and also update the level or answer, anything. Level is equal to 2, level is equal to 3, and then we go to the at the third level, and after that we go fourth level. Fourth level have a 3 element, 5 plus 11 plus 5. and the sum of three element is 21. Then it is also greater than the previous sum 70. Then we update the max is equal to 21 and level is equal to 4. And this is a last value. Then we return the value of the level. Go through the code. Let's see the code. Here we first we check the, if root node is null, then we return null. And here in max we store the integer minimum value to compare any other node. And level 1 we start with level 1 and answer is equal to 0. Answer is basically a level where which have maximum sum. And here we go through the breadth first search. Then we apply the queue. To implement the queue we are using the linked list. First we add the root node and iterate over the its children. Iterate over the root node. And size is storing the element of queue. Initially we store the 1. Then it will be this loop, for loop, it runs once time. And the here is local is used to store the value of the value of each level sum. Here we store first at the first level we store it stores 1, and after that here if left is equal to not null, then we add the left children of the root and also right children of the root if they are not null. And at the last we update the value of local by adding the root value or front value. After that we calculate the max. If here we check the max if it is greater than or less than. If max is less than the local, then we update the max and level and answer also. After that we increase the value of level and return the answer. We are submitting here. We got the correct output. That's all.